just to let you know, I'm a solar system ambassador, which means that I speak on behalf of NASA and the Jet Propulsion Laboratory, although anything I say are my own opinions and don't have any reflection of what NASA officially gives you. But I am going to give you the information that we have about, and I'm sorry about the dog, about Mars. Um, and my screen is frozen. Oh, there it is.
Should
Okay.
we have should we have questions, Dr. Farber? Would you prefer we raise our hands or wait until the end, put them in the chat?
Whichever people want to do is okay with me.
Okay.
Okay. So I show this Mars bar because I usually get the joke when I ask, what do you think of when you hear the word Mars? And I usually get somebody joking about the fact that it's a candy bar. But I'm not talking about candy bars today. I'm going to be talking about Mars, the planet. So the path of Mars exploration has been very interesting. And I call it myth to magic, and you'll see why as we go along. The ancient people saw Mars just by looking up in the sky and seeing this red dot that moved and through the night. And they described it as a god, and I'll tell you why. Then we had the invention of the telescope, and Mars could actually be seen through the telescope, but there was a lot of misinterpretation about what we were seeing because it's so far away. And then finally, there were probes. Early on in the 1970s, there were probes that flew by Mars, and we thought initially it was a dead planet, and it had always been a dead planet. And now we know something very, very different. And I'll be able to tell you all about that. So the ancients Mars was one of the first planets described. And the term planet is Greek for wanderer. So what it is that unlike stars, which have fixed positions because they're so far away, planets change their location in the sky throughout the night and throughout the seasons. Mars was first described, or planets were first described by Aboriginal Australians, but they didn't know exactly what they were. The Greek astronomers called Mars Ares, and in Rome it was called Mars, or both were the god of war, basically. And the reason was because Mars has a fiery personality with rash decisions. The fiery personality is that it's blood red in color because of the iron oxide that's on the planet. And it has a change in brightness due to the orbit of Mars. So they thought of it as a pulsating heart and blood. And they also attributed omens to its appearance and motion. So this is the actual depiction in ancient Greece of Mars, but more modern depiction would be something like this. Well, the orbit of Mars was first worked out by Johannes Kepler in 1609, and he realized that Mars's orbit is very oval. It's closest to the sun at 206 million miles away, and then farthest at almost 250 million miles away. So this is a very eccentric orbit, unlike most of the planets, which are fairly circular, although not exactly circular. And this causes a lot of eccentricity in its seasons. Earth has a tilt. The axis of Earth is tilted to about 23 degrees, and that's what allows our seasons. And Mars is fairly close at 25 degrees. But because of that very eccentric orbit, there are much longer, colder winters in the southern hemisphere. And in the northern hemisphere, the summers are much warmer, but they're shorter. And you can see the orbit. Earth's orbit is almost circular, not quite, but it's fairly so. Whereas Mars, you
I'm only
see,
Doctor.
I'm sorry,
I'm not seeing slides. I'm only seeing you.
uh, I'm sharing the slides. You're
I
not,
think that might just be you, Fran. The mode that you have your Zoom. We can see the slides on our end.
okay. All right, I just want to make sure. Um, the Mars at what we call perihelion, which is the closest approach to the sun, you see it's about this far from the sun, and you see the distance from Earth to Mars is this amount. Well, at its the other side, uh, it's much further away from Earth and much further away from the sun. And it's this eccentricity that allows for those differences in seasons. Now, the first telescopes were developed in the 1600s. And by now we knew that people knew that Mars wasn't a god, it was just a planet. And Christian Huygens in 1659 discovered that there were markings on Mars. And then Giovanni Cassini, shortly thereafter, spotted bright areas at the poles of Mars, which he postulated were ice. And then in the 1830s, Wilhelm Bohr and Johann von Madler mapped all the light and dark areas on Mars. And you can see that basically the northern hemisphere of Mars has this fairly bright orangish color, whereas the southern hemisphere has this darkish grayish areas, and then the bright areas are at the poles. You don't see the northern pole only because it's tilted away from us in these drawings. In the late 1800s, there began to be some theories about what all these things meant, all these markings on Mars. In the 1860s, John Phillips postulated about the markings and thought that the reddish northern hemisphere that I showed you is land, whereas the grayish southern hemisphere he postulated was water. So this was just sort of what he thought was going on. Schiaparelli, who later in the 1800s saw these markings and believed them to be canali or canals. And then Percival Lowell, who was British in the late 1800s and early 1900s, postulated that the blue-green areas are seas, not just water, and that the canals were actually made by intelligent beings in order to bring the water from the seas in the south to the arid areas in the north. And you can see that some of these drawings were quite fanciful, with all these myriad of canals on Mars, and the sort of the water and ice here in the south being funneled to the north through these canals. Well, we then got the understanding that no, there aren't real canals, and no, there aren't intelligent beings. Edward Barnard, who was a California astronomer, advised caution as to the fact that there might be other explanations. And Alfred Wallace calculated the temperature on Mars would be bitterly cold and wouldn't support intelligent beings living there. And then in 1909, further observation actually found the markings weren't actually canals at all. What they are basically these cracks in the crust due to the shrinking of Mars from the time it was formed. And these cracks cause these deep sort of channels or canyons to occur on Mars, but they're not canals. Well, then we move a whole century further to the early 1960s. And this finally put to rest the idea of intelligent life. Mariner 4 passed within 6,000 miles of Earth, found that its temperature was less than 1% of Earth's. The pressure was 1% or less. And the atmosphere that was there was largely made up of carbon dioxide. So again, this wouldn't support intelligent life. In 1969, Mariner 6 passed within 2,000 miles of Mars, found there were no Earth-like features, just craters, and that the poles were made up of solid carbon dioxide, otherwise known as dry ice. And you look at it and you see these large craters and then these smaller craters in between, and you think this looks very much like the moon, which is just an arid, arid body without any kinds of life or anything else on it. The USSR sent 2 orbiters to Mars in 1971. They couldn't visualize the surface because of a global dust storm. But they did determine that the temperatures on Mars were very cold, minus 166 degrees Fahrenheit at the poles, minus 135 to positive 10 degrees Fahrenheit on the rest of Mars. And US Mariner 9 got some of the best images of Mars. Again, it looked like just a dead body. They did, however, see the biggest volcano in the solar system, which was on Mars. And again, you see these sort of many craters, damage from other asteroid hits on Mars. This, if I didn't tell you that it was Mars, you could easily assume it was either Mercury or Moon because they look very similar. This one area is not a crater. This is Olympus Mons, which is the biggest volcano in the solar system. It's 388 miles across at the base, and that's about the size of Arizona. And it's about 80,000 feet tall. And if you remember, Mount Everest, excuse me, the tallest mountain on Earth is 29,000 feet. So it's more than twice as tall as Mount Everest. And this is a better view, which was taken much more recently. And you see how large it is and the caldera at the top, indicating it was a volcano. Well, then we got going. Mars was of interest to NASA and to people generally. And the myth got turned into magic. There were orbiters, like in 1976, the Viking orbiters and landers. The orbiters' findings showed an Earth-like style, excuse me, of valley networks. And it looked like these were small tributaries merging into rivers, along with some deltas. Now, none of this was actually water, but it looked like there was liquid water in Mars's past. And then a Viking 1 lander soft landed on Mars and found these highly reactive compounds in the soil that only could have been found if there was water present. And you see some of these tributaries that come together and turn into rivers, and other places where there are deltas that come about. And again, these aren't real rivers now, they're dried up, but it looks like there were these rivers in the past. And this is just a selfie of one of the Viking landers that it took. And you see that the soil it sees is very arid, indicating there's no water now, at least on the surface. Well, then there was more recently a much more advanced orbiter in March of 1999, and it had high resolution images. And what it found were actually sedimentary layers, meaning there was some kind of geologic activity in the past. And this could be just wind deposits of sand, although no one knows why it would adhere like that and four rocky layers. There could have been meteoroid events, but again, it wouldn't form these solid layers. There could have been volcanic eruptions, and we know there was at least one volcano on Mars, although we don't see evidence of many others. There's a few, but not a lot. And so the conclusion was, since these were seen on lots of different areas over Mars, that there was water at some point on Mars. And you can see the orbiter looks at these and sees clearly these layers down here as well up here. And this was in very large areas on Mars. Something like this, where it's clearly sedimentary in nature. And the most logical explanation is these were different eras in which water existed on Mars. The problems with landers was most importantly that they were stuck in one location. We wanted to be able to rove around and see what else was present, and they just were in just one limited area. They also had limited number and complexity of instruments since they were smaller, and a limited ability to transmit images since the equipment wasn't as advanced as it is now. So NASA experimented with rovers. The first was in July of 1997, and this really was a technological mission, seeing could we have a small rover, which was about the size of a microwave oven, roaming about on Mars that we had control of. It did, however, develop a 3D representation of the surface, and it did look at some of the chemistry of loose dust and soil in the immediate area where it landed. And then in 2004 were Spirit and Opportunity. These landed in areas where we thought there was probably water in the past. Spirit was in an area of hot springs, we think. Opportunity landed in an area where there were sedimentary rocks and where this mineral gyrosite was found, which indicated a watery environment. However, the only thing with the rovers is this is how they landed. They had a shell to prevent overheating of the rover on its way through the Martian atmosphere. But then when it got close to the surface, there were these landing bags that were puffed up. And so this thing bounced along the surface for several miles until finally it stopped. And the bags deflated, leaving the platform and the rover Sojourner. And you could see that Sojourner has gotten up close to one of the large rocks there and is taking pieces of it. And this is a close-up of that kind of performance where Sojourner is drilling into the rock. Spirit and Opportunity were bigger. They were the size of maybe a very small golf cart, not much, maybe half the size of a golf cart, something like that, and certainly not as tall as a golf cart. But they were more capable. They had some better instruments. They did have these solar panels on it, which powered it, and we'll talk about that in a little bit. But it was able to rove about. And you see that basically one of the areas that Spirit wrote about was in this area where we believe were ancient hot springs, and you see these are salts on the surface where it was located. And these are wheel tracks of opportunity, and these are sedimentary rocks that it got near, and it was shown to be sedimentary. And you can see these here, clearly sedimentary rocks indicating water in the past, or at least what we thought was water. We couldn't prove it yet. So was there more evidence to support it? Because if present, it might indicate a very different ancient Mars than we had been thinking. Not only wetter, but also warmer. And maybe an atmosphere that was thicker. And that gave us the idea that there was a possibility of some at least previous life on Mars. The other question was it ancient, or is there ongoing life now? And so a number of orbiters and landers were launched. Odyssey was a polar orbiter that was launched in 2001. And through the instruments, they found a lot of ground ice under the Martian surface. And this is throughout the land on Mars. They were unsure if this ice was water or carbon dioxide, though. And you could see that Odyssey found all this ice just under the surface throughout most of the planet. And then the Mars Reconnaissance Orbiter achieved Mars orbit in 2006. And there were some interesting findings. There were gullies that they found that still were forming on Mars. So there were dry flows of either dust or soil. And they knew this because with each orbit, it changed. Also, they found dark material flowing down rocky slopes. And they believe this was actually outbursts of groundwater. So Mars is an active planet and not dead at all. And these are these gullies of material flowing down. But these are the gullies of what we believe to be outbursts of water carrying this dark minerals down the slopes. The Phoenix project also landed in the Martian Arctic in May of 2008. They dug trenches exposing these white patches, and the spectrometer confirmed that these were actually water ice. They weren't carbon dioxide, they were actually water ice. And that proved that there was water ice in the subsurface Mars. This is the artist concept of the Phoenix Project lander, and you can see it had this arm with a trench at the end that actually dug trenches. And these are those subsurface white patches. This is only a couple of inches below the surface. And we see that there's all this white ice there. Well, then NASA got interested in developing larger rovers. We needed more information about this water. We wanted proof that Mars had a habitable environment. But there were problems with the smaller rovers. There weren't enough instruments, as I said. The solar panels were designed to last only a year or less. Some of them lasted longer. And in fact, Opportunity lasted only until recently. But they would occasionally get covered with dust and be inoperative for a time being. And then the dust storm would blow the sand off and it would be active again. So it was kind of a hit or miss type phenomenon. The other thing is we wanted to be able to land them in very specific positions. And you couldn't do that with landing bags. It could be anywhere within several miles. So therefore, larger rovers were designed and built. And also, they designed a new way of landing. The two rovers were Curiosity and Perseverance. They're about as large as a small SUV. So they're hefty. They weigh about a ton each. There are a large number of instruments and cameras. Curiosity, for example, has about 17 cameras on it and 4 spectrometers. And they're powered by a thermoelectric power generator instead of solar cells, meaning they can last for a much longer period of time. This was Curiosity when it first landed, a month or two after it first landed. And you see it's still white as it had been on Earth. This is Curiosity after 10 years on Mars. It actually has now gone 11 years on Mars and still going strong. These are these thermoelectric power generators, and the way they work is in this area is a chunk of plutonium, and plutonium is a radioactive substance, so that it naturally decays on its own into more stable elements. But as it does so, it gives off not only particles, but gives off heat. And that heat can be converted into electricity. And that's what powers the rover. The landing is a very complex system. It's a heat shield, parachutes, rockets, and a crane, all of which designed to pinpoint the location of the rover. And this is how it works. The spacecraft comes in. It has this shell to protect everything inside as it heats up during reentry. The reentry slows it from the 25,000 miles an hour it's going down eventually to less than 100 miles an hour. And all that's converted into heat. After a while, a parachute is deployed. The heat shield separates because it's no longer needed. It's down where it's not heating up anymore. It develops a radar lock. The package comes out, and there are powered rockets to slow its descent further. It hovers about 50 feet above the surface and deploys the actual rover by a crane. You can see that here. And then the package itself flies away. And so this is what it sort of looks like by artist's conception as it's lowering the rover down onto the surface. So Curiosity was immensely successful. It landed exactly where it was intended, within a few hundred yards of where it was designed to be. Designed to last 2 years, it landed in 2012, so it's still functioning now 11 years later, and now having traveled more than 18 miles of the surface. And it's found many important findings. The first thing was the surface all around the landing site was made of pebbles, all sedimentary, and many of the rocks and pebbles that were there are rounded. And the only way you can explain that is erosion due to liquid water. Further away, there's still this extensive sedimentary system seen. And the water that was at the landing site was believed to be, based on the spectrometer, believed to be initially, when it was present, was low in salinity, low in salt, and a neutral pH. And in other words, absolutely ideal for forming life. Curiosity also drilled into the surface and found most of the building blocks of life: carbon, oxygen, nitrogen, hydrogen, phosphorus, and sulfur, all were present. And the spectrometer also found organic molecules, so carbon-based molecules that were on the surface. Now, it could mean two things. This can happen naturally. We know that. And especially from the radiation of the sun, can change simple carbon-based molecules into more complex ones. But it also could indicate that these were biologic in origin, meaning ancient life. We're not sure yet. This was the Curiosity landing site. You see these conglomerate rocks, and on Earth you see this in ancient riverbeds or areas where there were rivers, because the the sand and silt all come together and form a rock. And these were the pebbles. And you see they're all rounded, not sharp. And that indicates erosion by liquid water. There was also recent evidence of water. Curiosity found very clear evidence of water because they now know that at least a Martian lake did exist. They found these ripples in dried up rock, indicating that it was actually a lake. The other thing is radar and seismographic evidence from orbiters have found that there's saltwater lakes under the ice caps at the poles. And there actually, in the rest of Mars, is a water table that's actually been found. So there is water underneath the surface on Mars today. These are the ripples in this lake, and you can see that basically this indicates a lake did exist in this area. Perseverance landed in 2021 at Jezero crater. Its location was a river outflow channel in Delta, and that's the best place to look for ancient life because as the river comes down, it slows at the delta and sort of drops all the silt and mud and rock. And it would be the area where life would exist if it did exist. And so Perseverance has been drilling core samples, which it has stored in titanium tubes, and I'll get to why in a minute. It also had a helicopter attached as a trial, and the helicopter was named Ingenuity. And I'll talk about that. This is the landing site of Perseverance, whereas Curiosity landed a few hundred yards from its landing site. Perseverance had a more advanced GPS system on board, sort of GPS. It wasn't because Mars doesn't have GPS, but it was it was a landing system based on the formations on Mars. And it was able to land Perseverance in less than 100 yards from where it was intended to land. So you can see all these rocks and stuff built up because this was at that delta site. Again, these sort of conglomerate eroded type of rocks. This is Ingenuity. Because the Martian atmosphere has only 1% the pressure of Earth, it has these two contra-rotating rotors, that rotate at about 30,000 RPM, something like that. And it was only supposed to do 5 trial runs just to see if we could get a helicopter type device on Mars that would function. It's already done more than 50 flights and has actually done useful work finding areas where Perseverance should look. So there is intended to be a future mission. Perseverance is collecting these core samples, as I said, and storing them in these titanium tubes. Within the next 10 years, hopefully 7 to 10 years, a return mission has been planned. The lander will land next to Perseverance. It will obtain those samples that have been collected in those tubes and return them to Earth in order to be studied. And the main plan is to determine if those organic molecules are just natural occurrences or are they actually biologic, which would indicate if they are biologic, that there was actually ancient life on Mars at some point. So this is the sample return lander that will land. And you can see it's got one of those tubes in its arm, which we'll put in here in a container that'll be inside that rocket. The rocket would be in the lander and would launch from the lander. It would meet up with the Earth return vehicle, which would then return to Earth and return that container. Now, we know we can sort of do this because we've done this with an asteroid, although it didn't have we didn't land on the asteroid, but the spacecraft took some samples from that asteroid into a container, which then returned to Earth safely and is now being evaluated. So we know that the technology exists, we just have to build it. So what have we learned? We learned that the surface of Mars is extremely arid. It's the surface itself has no water on it. It has the dry ice at the poles, but otherwise has no water on the surface. But there is water present in the subsurface soil and lakes, and in the lakes or seas, whatever they are, that are saltwater, that lie below the ice caps. We also know that Mars is not dead. There are active changes at the surface, both soil and water outbursts. We know that Mars probably had a habitable environment at some point in time, based on all of the evidence we have from the rovers. And we know that life might have existed on Mars. There's a good chance it did. One of the other things is the European Space Agency Mars Express. This was an orbiter, found traces of methane gas in the atmosphere. And methane gas also can occur naturally, but it also is a byproduct of biologic life. And so there's a possibility that there could even be life on Mars today. We just don't know. And the plan is to try to find out sometime in the near future. So we started early on with Sojourner. That just was an experiment to see if we could operate a rover on Mars. Spirit and Opportunity were actual rovers, did a lot of work, but weren't totally sufficient to be able to find out whether there was water. Then Curiosity and Perseverance, which were much bigger, much more capable, landed, and we have definitively proved, I think, that at least some point in time there was water on Mars's surface, and that Mars did have a habitable environment in the past. And the plan is to actually have boots on Mars, i.e. land on Mars with humans sometime in the future to be able to explore it further. And with that, I will stop and ask if there are any questions.
Thank you so much for that talk. I will go ahead and monitor the chat, but you're also free to raise your hand or unmute yourself if you'd like to ask a question. You said, I'll just start it off. You said one of the goals might be to have boots on Mars. How soon in the future would you think that would be?
That's always the question. So it's hard to know. Mars is a really big challenge. Going to the moon is very easy. It's 2.5 days. Even there, it would be a challenge to set up a base on the surface. That's probably, we're talking about 5 or more years into the future. So the reason for setting up a base on the moon is because if you set up a base on the moon and then set up a space station around the moon, you can launch from there. And the energy needed to go to Mars from the moon is much, much less than going from Earth. So you can build a much larger spacecraft, one that's capable of going to Mars. The reason I say that is because Mars, the trip to Mars is anywhere from 2.5 to 3 years in length. Not a week or two. It's 2.5 to 3 years. The reason for that is Mars is anywhere from about 6 to 9 months away at its closest by rocket, by spacecraft. Now, if we we're using an ion engine now in one of the missions going to asteroids, unmanned. If we develop an engine that's ion-based, that's capable of getting to Mars sooner, it would shorten the distance. It would be a couple of months instead of 6 to 9 months. That would help. But you still would have to wait a year until Mars came back to the point where it would be less cumbersome to get back to Earth. So it's anywhere from a 2 to 3 year mission, even at its shortest, which means you have to have a base set up on Mars to be self-sufficient. So all of that, and there are the challenges of radiation in space as well for 2 to 3 years. So those are very big challenges that we are looking into, but haven't met yet. So when will it occur? My best guess is about probably 10 to 20 years from now. It could be longer.
That's a lot sooner than I would think. Wow. That's in the near future. Okay.
In the near future. But that assumes that things go exactly as we plan, which never happens. And second of all, that probably not just the United States. It would have to be a very collaborative effort with everybody putting in a lot of money and political will into doing this. So we'd all have to come together to decide that this is worth it. But that's making that assumption. It could be within about 20 years.
Thank you. Other questions?
Hi, it's Becky. I'm just wondering if any other countries are trying to also send people to Mars in the near future.
The country that is looking like it might, and we don't know because they don't really communicate with us, would be China. China now has a space station around the Earth. They are talking about having a base on the moon. The reason for having a base on the moon would be to go on to Mars. We've already been to the moon, so the political value of going to Mars would be much greater. Going to the moon doesn't mean much anymore. So it might be that China is looking to go to Mars, but we have not collaborated nor even communicated about that. The other faction that is very interested in going to Mars is Elon Musk as an individual. He unfortunately does not have the infrastructure. He has a rocket and he can develop the capsule, but it requires a lot more than that. It requires an entire base and monitoring from Earth and stuff like that. So he would need the infrastructure of NASA to be able to do it. Could there be a collaboration between Elon Musk and NASA to go to Mars? Yes, that would be possible, but it hasn't been talked about, at least publicly, that I know of yet.
Thank you.
Any other questions?
In terms of just getting back to Elon Musk, he and NASA have been working together. Not to go to Mars, but Elon Musk now does all of the shuttling, both of astronauts and cargo, up and back to the International Space Station. Although there will be involvement with Boeing, I believe, as well, or either Boeing or I think it's Boeing, who will be involved as well. But Elon Musk has been collaborating with NASA for quite a while, going up and back to the International Space Station. Elon Musk also developed and built the first, is building the first of the new moon landers to go to the moon. in the Artemis program. So he's been collaborating with NASA, and I would see that as a possibility in terms of Mars.
So he's like an Uber driver.
I'm sorry?
So he's like an Uber driver.
He is an Uber driver right now. I think that is true. I think he has a lot more aspirations than that. He did send one of his cars in orbit around Mars, so I think he plans on doing that eventually.
Are they, I know in the past they've done testing on animals being sent to space before humans were.
Right.
Would that be a possibility for Mars as well? I'm not sure if that was discussed, or I might have missed that.
I don't think that's necessary. We tested animals going into space before humans did because we had no idea what space was going to be. We've now had 60 years of experience in space. So I think we're comfortable being in space. The issue is, and we know what the challenges are, the issue is getting to Mars and sustaining ourselves on Mars. So it's not a question of could an animal survive going to Mars. We know that basically if we develop the right technology, the answer would be yes, in which case a human could do it too.
Thank you. Other questions from our audience? And I know that you will be back to give a talk on astrobiology. Do you want to give a little blurb on what it is while we are all here?
Sure, I'd be delighted to. So, astrobiology, we're looking in two places. And astrobiology, when we talk about astrobiology, everybody says, you mean you're looking for little green aliens? No, that's not what I'm talking about. We're talking about any kind of life other than on Earth. I will admit we have not found actual life elsewhere yet, nor have we had any hint of intelligent life elsewhere yet. But there are promising findings, both in some planets around other stars, as well as other objects in our own solar system that indicate there's a possibility of life elsewhere as we speak. And I'll talk about that next time. We haven't found it yet, but we're close to it.
Thank you. All right, so last call for questions, comments.
Oh, and the next one on astrobiology, for everybody to know, will be on Thursday the 16th. And I think we agreed to change the time to 11 a.m. instead of noon. 11 is better for me, and I hope will be better for everybody else.
Yes, we'll go ahead and market the change to everyone via email so everyone is aware. But otherwise, thank you so much, Dr. Farber, for this presentation. It has been recorded and we will post on YouTube. If you want to go back and review anything he talked about, we do appreciate it. Thank you so much.
My pleasure.
All right. Goodbye, everyone.
Bye-bye.
Goodbye. Thank you.